So today, we'll be talking about encryption algorithms. And for the purpose of discussion, we'll describe encryption as a conversion of electronic data into another form called ciphertext, which cannot be easily understood by anyone except unauthorized parties. The word came from the Greek word cryptos, meaning hidden or secret. Believe it or not, the use of encryption is nearly as old as an art of communication itself, as early as 1900 BC by Egyptians using symbols. The encryption process spread throughout the entire globe. However, it wasn't until mid-1970s that encryption took a major leap forward when Whitfield Diffie and Martin Hellman published a paper called New Direction in Cryptography, which solved one of the fundamental problems of cryptography, namely how to secure, distribute the encryption key to those who need it. Currently, there are two main types of encryption: symmetric key, also known as shared secret key, and asymmetric key, also known as public key or public-private key. In symmetric key encryption, the same key is used to encrypt and decrypt the message. If two parties want to exchange encrypted message securely, they must both possess a copy of the same symmetric key. Symmetric key cryptography is often used for encrypting large amounts of data because it is computationally faster than asymmetric cryptography. Let's start with the Data Encryption Standard, or DES. It was once a predominant symmetric key algorithm for the encryption of electronic data. It was highly influential in the advancement of modern cryptography and the academic world. Developed in the early 1970s at IBM and based on the early design by Horst Fistel, the algorithm was submitted to the National Bureau of Standards, or NBS, following the agency's invitation to propose a candidate for protection of sensitive and classified electronic government data. In 1976, after consultation with the National Security Agency, the NBS eventually selected a slightly modified version strengthened against differential cryptanalysis but weakened against brute force attack, which was published as an official Federal Information Processing Standard for the United States in 1977. DES is now considered to be insecure for many applications. This is mainly due to a 56-bit key size being too small. In January 1999, Distributed.net and the Electronic Frontier Foundation collaborated to publicly break a DES key in 22 hours and 15 minutes. For here, triple DES is born. It is the symmetric key block cipher which applies DES cipher algorithm 3 times each data block. The original DES cipher's key size of 56-bit was generally sufficient when the algorithm was designed, but availability of increasing computational power made brute force attack feasible. Triple DES provides a relatively simple method of increasing the key size of DES to protect against such attack without the need of design and completely new block cipher algorithm. Another type of algorithm is what we call RC, which standard for reverse cipher, or alternatively runs code. RC has 3 types: RC2, RC4, and RC5. RC2 is symmetric key block cipher designed by Ronald Rivest. In 1987, it uses key expansion algorithm by which an expanded key consisting of 16-bit words is produces depending in a complicated way on every bit of the supplied variable length input key. RC4 succeeds RC2, which is used in web and WPA and encryption protocols commonly used on wireless routers. RC4 was originally very widely used due to its simplicity and speed. Typically, 16-byte keys are used for strong encryption, but shortly, key lengths are also widely used due to export restriction. RC4 is also very fast stream cipher which generates a pseudo-random stream used for XORing. Its key size is 40 to 2048 bytes. And lastly, RC5 is symmetrically block cipher notable for its simplicity. A key feature of RC5 is the use the data-depending rotations. RC5 also consists of number and modular additions and exclusive or XORs. The encryption and decryption routines can be specified in few lines of codes. The tantalizing simplicity of algorithm together with the novelty of the data-depending rotations has made RC5 as attractive object of study for cryptanalysis. We also have AES, or Advanced Encryption Standard, as one of the common algorithms used today. It is symmetric block cipher used by US government to protect classified information, and it is implemented in software and hardware throughout world and encryption sensitive data. AES is based on Rijndael cipher developed by two Belgian cryptographers, Johan Damon and Vincent Ridgman, who submitted the proposal to NIST during the AES selection process. Rijndael is the family of cipher with different key and block sizes, although it is restricted to a block size of 128 bits and key sizes of 128, 192, 256, which we call AES 128, AES 192, AES 256, respectively. There are a number of features of AES such as it is stronger and faster than triple DES. It provides full specification and design details and is a software implementable in C and Java. The most commonly used algorithm is what we call the RSA. RSA is an algorithm used to modern computers to encrypt and decrypt messages. RSA is named after Ron Rivest, Adi Shamir, and Leonard Adleman, who invented the first publicly described in 1978. RSA stands for Rivest, Shamir, Adleman, derived from their last name. It is an asymmetric crypto system for public key encryption and is widely used for securing sensitive data, particularly when being sent over the insecure Networks such as internet. Asymmetric means uses two different but mathematically linked keys, one public, one private. Public key can be shared with everyone, whereas the private key must be kept secret. In RSA cryptography, both the public and private keys can encrypt a message. The opposite key from one used to encrypt a message is used to decrypt it. RSA provides a method of assuring the confidentiality, integrity, and authenticity of electronic communications and data storage. In the humble opinion, RSA, in its simplicity, is easy to understand, but it's very hard to break. It is definitely one of the most widely used and most useful tool for building cryptographic protocols that it's built in a secure, strong, and wonderful cryptographic algorithm. So, why encryption? One word, secure. It is a major priority for businesses of any size to guard them from every security breaches that can cost them millions every year. Even if you don't have millions to lose protecting what you don't have, you should be a high priority. This protection is important for everyone. It protects our data from competitors, criminals, malicious attackers. The two forms of encryption you use most often are HTTPS URLs on your browser and the handset to tower link for your cell phone calls. For me, encryption is an interesting piece of technology that works by scrambling data so it is unreadable by unintended parties. It is also your last defense against malicious security crackers violating your privacy. When all other means of protecting the data on your computer prove fruitless, encryption is the last barrier against your most sensitive data being accessible to people who simply should not have it. Before I end, I'd like to leave you guys with a joke. How can you tell the difference between good cryptography joke and random string of words? You cannot. They are indistinguishable. Thank you for listening, guys, and stay protected.